Welcome back to your first lesson on graphing quadratic equations. So in the previous video, we talked about some of the vocabulary, and now we're going to get to basically the steps and procedure. How do we actually go about graphing a quadratic? So in our previous unit, we spent a lot of time finding zeros. And remember, zeros are just x-intercepts. So if we want to find an x-intercept, remember back from our linear equations unit, we have to let y equal 0. So we substitute a 0 into the equation for y. Well, as soon as we have y equal to 0, we're going to have a quadratic equation equal to 0. We're going to be able to go ahead and use the zero product property. And remember, if things are not in factored form, meaning the parentheses, we may have to factor. So we're going to add that as a note on our first step here. Factor if necessary. All right. So we're going to work on these steps and the first example kind of at the same time. So I'll be flipping back and forth. So our first example here, it says graph the quadratic equation y equals x plus 2, x plus 4. So in our notes, we said we need to find the zeros, which means I need to let y equal 0. So here is where I'm going to replace the 0. So I'll have x plus 2 times x plus 4 equals 0. And some of you may not be happy with me because the 0 is supposed to be on the left-hand side of the equation because that's where the y is. But remember, an equation is just an equation, and the two sides are going to be equal no matter what side they're on. So I think most of us would prefer to have it in this order. So now, this is in factored form, and you can recognize that because it has the parentheses. So we're going to go ahead and apply the ZPP, which just means we're going to set each factor equal to 0, and then we're going to solve. So my answers for the zeros, x equals -2 and x equals -4. So -2, 0 and -4, 0. Now I'm going to go ahead and I'm going to put those on my graph right away. So -2, 0 and -4, 0. Now back in our factoring unit, we would graph zeros and we kind of just made a brief sketch. It didn't have a lot of detail, but we did talk about how to find the vertex. And hopefully you remember that the vertex is located right in the middle of the zeros. Now from our last lesson, we also noted that the axis of symmetry is right in the middle. So if I find the zeros, I can easily find the middle and I can sketch in that axis of symmetry. And I will label that axis of symmetry. So I've done a lot of math here without actually writing much math down. All right, so back to our steps here. Step number 2 is to find the x-coordinate of the vertex. Now the x-coordinate of the vertex is also going to be part of our axis of symmetry. So we just found that. So if you glance at our graph here, whoops, there we go. If you glance at our graph, it looks like our axis of symmetry. If we write the equation, x equals -3. Now, sometimes the numbers may be trickier to work with. So what I want to do is give you another way to find the x-coordinate of the vertex, and that's just average the zeros. So if I just generically call the zeros 0, 1 and 0, 2, if we're going to average those, we would add them together. So 0, 1 plus 0, 2. And then I would divide the whole thing by 2. Now, if you're going to type this in your calculator, you need to have parentheses around the top, or you need to add the zeros, hit enter, and then divide by 2. Otherwise, it's going to mess you up. So what I'm going to do over here is I'm going to find the vertex. And to find the x-coordinate, I have to take 0, 1, which is -2, plus 0, 2, which is negative 4, and then I have to divide that by 2. So I'm calling this Z1 and Z2 for 0, 1, and 0, 2. So you can do this in your calculator. If you hit enter on the top, you get negative 6 over 2, which is negative 3. And that gives us our axis of symmetry, which we could also find just by looking at the graph. So either way. Now, the vertex also has a y-coordinate. So we know that it's going to fall somewhere on that red dotted line, but we have to find exactly where. And here's how the equation is going to come back into play. So this y value is going to be found by simply substituting in x values. So if our x value is negative 3, I'm going to do negative 3 plus 2 times negative 3 plus 4. And negative 3 plus 2 is negative 1. Negative 3 plus 4 is 1. So my vertex is at negative 1. So I can now graph negative 3, negative 1, and there is the vertex. Now, we have our table of values, and what I'd like you to do is put the equation in the top here, and what I'm going to do is leave a little blank for where the x should be. Okay, and then we've always gone with the go-to values of negative 2, negative 1, 0, 1, and 2. But with a parabola, our most important point is the vertex, which is why there's a big star here. We are always going to put the vertex in the middle of our table because the vertex is kind of in the middle of our parabola. So I already know my vertex is negative 3, negative 1. And I'm not going to do any work. I'm just going to remind myself that that is the vertex. And then we just want to go kind of up and down. You can go up by 1s, you can go up by 2s. I guess I would suggest 1s. So negative 4, negative 5, negative 2, negative 1. And so if I take these values and I start replacing them, I would have y equals negative 5 plus 2 and negative 5 plus 4. And you can put that in your calculator. In fact, maybe press pause and check it out. You should come up with a y value of 3. So I'm going to go ahead and plot that. I'm going to go over to negative 5 and then 1, 2, 3. Now, I'm going to be smart about this because we've drawn in our axis of symmetry. So I know that negative 5, negative 3 is going to flip across the axis of symmetry and meet up with another point. So by doing that, if I go 2 units from my point over to the axis of symmetry, and then 2 units over, I'm going to get my new point, which happens to be negative 1, positive 3. So I got this point by using symmetry. And then negative 4, well, hey, I already found that negative 4, 0 was a point on my graph. I already have that marked. Negative 2, 0 was a point on my graph. Those were our x-intercepts or our zeros. And so I've got my parabola. And we're always going to require you to graph 5 points. So once you have 5 points, you're good to go. And then remember, it's a nice smooth curve. Connect those points and put the arrows on the end. Now, the only other thing we didn't fill out was our axis of symmetry. But like I said, we've already done that thinking. It just always has to be an equation. So make sure that you are always writing it as an equation. It is just a vertical line, so it's got to be x equals. I do want you to make a note that this form right here is factored form because we have it in parentheses already. So if we flip to example 2, you will notice, first of all, you'll notice that I have 2 y's in my equation, which is problematic. So let's just get rid of this here, pretend that's not there. So the equation that we have right now, this is standard form. And we don't know how to do anything in standard form. So what we want to do is we want to provide, or we want to actually go through the steps that we just practiced. So I need to go from standard form to factored form. So I'm also going to go back to my first step and I'm going to put the 0 in place of the y. So I've got x squared minus 10x plus 21 equals 0. Now we do have a quadratic trinomial. This is a 1, so we can go ahead and do the x method. We'd have a positive 21 and a negative 10. And if you think about your factors, we need a double negative because we have to multiply to a positive. We have to add to a negative, and 3 and 7 would be our choices. So our factors, x minus 3 and x minus 7. So this is now factored form. So I could actually rewrite the equation if I wanted. I don't need to. And then to find the zeros, we just set up our equations. And so we have our zeros as 3, 0 and 7, 0. So as we labeled in our previous example, this would be like Z1 and this would be Z2. And let's go ahead and plot those right away. So 1, 2, 3, 0, 4, 5, 6, 7, 0. So again, I think you can just look at the graph and find the axis of symmetry if you just average those together, or if you just go in the middle. So here's our axis. It is a vertical line, and you'll notice that that is at 5. So we could go ahead and fill in our axis of symmetry right away. And that's the line that all our points are going to flip across. So our vertex, we find our x coordinate by just adding the zeros together and dividing by 2. So 3 plus 7 is 10. 10 divided by 2 is 5, which agrees with what we just calculated for our axis of symmetry. To find the y value, you just need to put it back into the equation. So what I'm going to do is use my original equation. So I have kind of the template of the equation, and I'm going to replace my x values with 5. And you can do that in your calculator. It would be 25 minus 50, which is negative 25, plus 21, which gives us a negative 4. So our vertex is 5, negative 4. So I can go ahead and graph that as well. 5, 1, 2, 3, 4, negative 4. So on our table, we're always going to put our vertex in the middle. We don't have to show any work because we've already done that. And then we just want to probably go by ones. And I'm going to notice 3 and 7 are in my table. Those are my zeros. So I already have the x-intercept in there. So now what I'm going to do is kind of just set up the equation so that I can substitute the x values in there. So for 4, if I kind of copy that template down again, oops, I don't need the y, I guess. I would have something squared minus 10 times something plus 21. Now that something is just whatever number I'm going with. So 4 squared minus 10 times 4 plus 21. And you can evaluate that in your calculator. In fact, I'd encourage you to do that and press pause and then check out your answer. We would get negative 3. So let's go ahead and graph that. So 4, negative 3. But then I should know that on the other side of the axis of symmetry, I'm going to have a point that lines up. So I'm just going to plot this one right away. And I notice, hey, that's 6. So I do not need to do the work for that. So I just used symmetry. And here, it was just the x-intercept. So I have my 5 points, and I can go ahead and sketch my curve. Nice and smooth, arrows on the end. So we had 2 different examples here. Let me just recap. The first example was in factored form, and so we could just start by finding the zeros pretty easily. The second example was in standard form, and so we had to factor first. Once you're done with this video, you can now do some practice with both forms.